Today we are resuming lesson 5.5, Laws of Logarithms. And so far we have developed and used the laws of logs, where we applied the laws of log to base 10. We use it to simplify expressions. We write log as a sum and difference of logs, and use the laws of log to evaluate log expressions. We've completed individual questions using each one of these concepts. Today, we will look at more details, at some combination of questions that apply these four concepts or four goals we have completed so far. We will look at the first question. We were looking at using log of base, writing as a simplified expression, then we write sum difference of square and evaluate log expressions. So for the next two lessons, we are going to go complete questions regarding these concepts. Just remind you, we'll be using extensively the log laws, the product law, the quotient law, and the power law. And also the definition for logs. We'll be applying these. Also, all of these are related to the exponential rule. Let's look at the first example questions. And in this question, we are looking at using the law to simplify expressions. Okay, we are simply writing this as a single log. So let's look at the first example here. Here we given a log, and we asked to write them as a single log. Now, we call your log laws. In this first one here, we're going to use the product and the power law. So here we have the power law. Let's go back to my question. So based on the questions, we're going to apply either the quotient law, the power law, or the product law. So let's look at the first one. Log x plus 3 log y. Let's do the first one here. Remember, we are writing them as a single log. So we can put that aside here if you want. Let's look at the first one, a. Log x plus 3 log y. For this part here, we want to write this as single. We're going to reverse it. We're going to use the power law. Now your power law, we have k log b to the x is equal to log b x to the power k. So we're going to reverse this. So now we use the power law here. So we have log x plus log y 3. Now we combine these two using our product law. So we combine these, so we have log. Now, here we have x to the power 1, so we have here x times y3. And remember, we are using this final one here. X times y. In this case here, we're using x times y. remember to keep your exponent. We can simplify this and make this log xy to the power 3. Okay, let's look at b. We have log x plus 2 log y minus 4 log z. The first thing we want to do be we would like to, in this case here we have, we're going to use the power law here. Okay. So for step 1, we use the power law. So we end up with log x plus y squared minus, now here we have another one, we have use the power law for this guy here, for this second one. Now we're adding this part here. So we're going to use the product law. And that will give us log x times y squared minus log z4. Now we're subtracting. And just remember, okay, go back here. Once you see a negative, you know it's going to be the quotient law. If you see a plus, product law. If you see an exponent here, we're going back, power law. So here we use the product law. And now the quotient law. So log, now we're going to put a quotient. Now this would be xy squared divided by z to the power 4. So we have x times y squared divided by, don't forget your exponents. So this is your final answer. We have the final part here. We have c log 2 6 minus 3. Okay, now remember, we need a log of base 2. So we need to write 3 as a log of base 2. So step 1, write 3 as a log base 2. Now remember, back to our wonderful log rule here. We could change a whole number into a log by putting it into a base. Okay. So remember, we have like log e to the a 3 will be equal to 3. So I'm looking at 8, this is 3, this is equal to 3. So now, what is our base? Right. So if our base now becomes 2, this should be 2 to the power 3. Okay. So now this becomes log 2 So we can write 3. So 3 is equal to log 2 to the power 3. Or 2 to the power 8. So this can be now, so log 2 to the power 6 minus log 2, or we can write 8 here to make it simplified, 8. Just remember, that's 2 to the power 3. That's how we ended up with this guy here. It's the same as log. Since we need to have a similar base, because these log rules here only work, notice the bases are the same. They will not work if they're different. So now we can use the quotient law because it's subtracting. So now we use your quotient law or rule. So log 2 give me 6 divided by 8. And we can simplify that as log 2 3 over 4. So be careful whenever you're given the whole number, you need to change that into the log, and we are going to apply this principle here. The log definition for log. So this is our final answer. Okay. Well, we have to write each expression in terms of log A, log B, or log C. Now we are doing the opposite. So now they're giving us, for example, product, in this case, the quotient law, and you need to write expand. So let's look at the first one, A. We're looking at the quotient law here. So log A, B squared. So we use quotient. Law. So this gives me log A minus log B squared. Now we're going to use the power law now to extend this. So we have log A minus 2 log B. So final answer. B, we have log A squared B 1/3 over C. Again, here we'll use the quotient law. So we have log a squared b 1/3 minus log c. Next, we are going to use in this case, because we're multiplying, I'm going to use the product law. So use the product law here. We have log a squared plus log b to the 1/3 minus log c. Now we apply the power law. Apply the power law to, we have 2 log a plus 1/3 log b minus, now there's, realize this, log c. Now this satisfies what they're asking us to write the expression of log a, log b, or log c. So here, 2 log a plus 1/3 log b minus log c. And that's our final answer. One good advice is to always try and do these in stages. As you get more confidence with these, you could really do them all in one, but try to do them in stages for now. It will help you to avoid any mistakes, because it's easier to make a mistake with these. Here we have to find the value of each expression. In other words, what is equal to 3 log 9/6. Now, you could use a calculator to get the answers. We can verify it, but this is a non-calculated part of the course, so there's no calculator except to do your basic multiplication or addition or power. Let's look at evaluating, finding the value of this. I want to say so a say 3 log minus log. We will be applying all of the principles we've learned regarding laws of log. So we will be applying, that's why it's good if you can memorize these, although you'll have a formula sheet of these. We're applying these different laws and the log definitions. The first step is we will use the quotient law in the first place. To simplify towards the end. But before we do all of that, we want to change this into our simplified. So this gives me log of 3 minus log 9 to 72. Now we can simplify this further, and 6 to the power 3 give me 216. So we can say that log 9 to 216 minus log 9 to 72. Now the base are the same, so we are in safe territory right now. Now we will apply, so the first thing here we apply the power rule, the first case here. So we can put a note here. So from here, we apply the power rule, I should say, to get that, apply the power rule here. And here we simplify it. Now we'll apply the quotient. So it's going to be log 9, 216 divided by 72. If we do that, what do we get here? 216 divided by 72. Okay, 216 divided by 72 gives me, oops. That will give me 3. So that gives me log 9 to the power 3. Now, we need to find one of these here. This is the one is the most frequent one you'll be using here to find a value, n. So log a to the an equals n. But if you look at here now, this is not a to the a. So we need to convert the 3 into a 9. Write 3 as 9. So have the 3 as the same as the base. So we want to write 3 as a power of 9. So we're going to hear okay, so our goal is to end up with this log. That's the reason for having 3 the same as the base 9. So we want to write 3 as a power of 9. Now, 3 could be written as the square root of 9. So we can have 3 is equal to the square root of positive square root of 9. So this becomes this. See, it's getting to this point now. So now what we have here, log 9. Now square root of 9 could be written as 9 to the power half. This could be log 9 to the power half. I'm just rewriting this. Remember your exponential rule. Now, this now applies this rule here. Oh, it's kind of messy here. This. So there you go. The answer is a half. So the final answer is half. So that's why remember we use exponential rule here. And the one we were looking at is a fractional exponent. And we're also using log a to the an is equal to n. So our final answer is a half. B, question B. It's a little bit trickier now. So B. And here again, we're going to apply the same principle. So we have 2 log 4, 6 minus 3 log. We're going to use a power law to simplify. So this becomes log 4, 6 squared. We simplify that one step further, becomes log 4, 3 to the power 3 plus log 4, 12. Let's simplify this one step further. This becomes 6 times 6 is 36. Minus 4, 3 to the power 3 give you 27 plus 4 to the 12. Now we work from left to right, same as your order of operations. So we have, this is your quotient rule here. So the first step here, we apply the power rule, power law. But then we simplify. Next, we are going to apply our quotient rule, our law. So this gives me log 436 divided by 27 plus log 412. Now we can apply our product law. So we multiply. The base is the same here. So we have 36 times 12. And just remember what you're doing with your product law. You have b of x plus b of y. We multiply x and y. It's the same thing we're doing here. B of x, y, plus b of y, we multiply. So it gives me log 4, be 36 multiplied by 12 divided by 27. Pull this out, this will give me, okay, already put to be consistent across here. This gives me log 4. Now 36 times 12 divided by 27, maybe 26. Let's see what we get here. 36 times 12 divided by 27, 16. Okay, we have 16 here. Next, we're going to write 16 as a power of 4. And that is because we want to use this principle, right? Log d to the bn is equal to n. That's what we want. That's why we want this to be the power of 4. So it gives me log 4. Now, this gives me 4 to the power 2. Now, our result would be 2. So all that wonderful work, we ended up with a nice number 2. So we are bringing many concepts into use for these questions. So this is our question. So all of this here is equal to 2. And if you look at the first question, this is equal to 2. A half, sorry. We will look at a few other questions that simplifying log. I'll just go through a few of those and writing log as a single expression. This is some quick questions here. We look at simplify each expression. Use a calculator to verify. So a little bit just to get your quick starter. So now we apply, in case we have the product rule. So we have the product rule here. Or product law, I should say. So this gives me log 6 times 5, which is equal to log 30. Now I can verify that in my calculator. I can go here. Because if you're looking at base 10, this is base 10, our calculator is by default is base 10, so we have log 6 plus log 5 gives me 5.6, and I have log 30. If I put log 30, should give me the same result. Oh, no, 6 and 5, what did I do? Oh, I incorrect here. I have added here. I didn't include my log. So let's try that again. Log 6 plus log 5. And there it is. I'm on the right track. So that is correct. So verify. Using calculator, we have log 6 plus log 5 is equal to 1.4771 goes on. And log 30 is the same thing. This one here, we're going to use the power law. So log 2 to the power 3, which gives me log 8. So we can verify that. We can go back to original question. So verify 3 log 2 is equal to 3, it's clear, 3 log 2.90, 0.903, and log 8 is also 0.903. In this case, we use a quotient law. So log 48 over 6, it gives me log 8. So we should have, so verify log 8, it was 903. And now we have log 48 minus log 6. Should give us the same result. Let's see what log 48 minus log 6, 0.9. Here we're going to use our product law. So log 8 multiplied by 5, we log 40. So let's test. So verify. So log 40 equal to, let's try the log 40, 1.6020. And now we have a log. Log 8 plus log, so log 8 plus log 5 this is a quick one, applying the quotient or how here, first one here we apply the product law, power law, quotient law, and product law. So we are applying our laws frequently. So our laws of law. We'll try one final example question for today. The next questions next lesson, I should say, sorry. Next lesson, we'll be using strategies to prove the product law, the quotient law, and the power law. And also we'll be looking at different strategies for solving log. So here we need to write each expression as single log, and here we're going to apply, because we're subtracting, here we have, first we're going to apply our power law, and then our quotient law, because we're subtracting. So power law, so that would give us log x minus, then we use a quotient law. So this would be like our x and y. Next, we apply our, first thing we apply our power law. So power law for both of these. So we try the power law first. So give me log x to the half plus log y to 3. Oh, then we use our product. And if you'd like to write it nice and compact, it could be x half first thing we'd apply the power laws for all three of them. Okay, let's see how it goes for this process. So first of all, the power law. So equal log 5x to 2/3 minus log 5y forward minus 5z3. Now this is where you have to be careful, because you have a minus and a minus. We want to make this into a plus right away. So if you put a minus here and put a bracket around this becomes plus. Okay, so we have log 5x to 2/3 minus plus log now we'll use our brackets first, because we're, remember, order of operation, use to do the bracket first. So we're going to use, in this case, so the first step here, we have the power law. Now here we're combining two expressions, and next we are going to apply the product law. So we have log 5. Notice we have a negative, we'll end up with using a quotient law also. So we combine these, we have log 5 y to the 4th multiplied by looks kind of cluttered, so I'm going to remove all that. I'm going to put log. So y4 set 3. Now I'll apply the quotient law. Log 5 because the space is the same. So log 5. So it will be x to third divided by y fourth z3. The final part here. Okay. So I'm going to use space here. This is a little bit easier now. Remember, we have to write 5, right? It's a power of 2. So we are using this principle again. The log. So 5 could be written as, not really change this into 25. So 5 could be written as, so we change, let's write it out here. So write 5. So 5 could be written as 5 is equal to the square root of 25. So we have that as 25 to the half, which gives me 5. So we write that as 2 to the power of 5. So let's get that as, so 2 to the power of 5. So log 2 so we're writing that as, gee, this wouldn't work there. So we're going to make this as 5, because we write it as a base 2 here. So that'll give us 2 be 50. Let's see, 2 to the power of 5. That will give us what? 2 to the power of 5, 32. So we write 5, 2 to the power of 5, which is 32. So we have here, so 5 could be written as 2 to the power of 5. And we're basically rewriting it. So now we'll have 2 to 2 to the power of 5 gives me, on my left side here, I have log 2 32 plus of 2 to the x. So use my product law here. So log 2 to 32 times x, which is log 2 32x. So we're writing 5 in this case as 2 to the power of 2. So that concludes our lesson for today, and our main goal is We need a law of laws of logs to simplify expression. We write it as a sum or difference of log, and also to evaluate log expressions. We applied extensively the laws of log